Michael Woods is going to give us our last talk this afternoon session before we head to our coffee break, is going to tell us about some of the standards that are being encouraged and applied out there. So without further ado, Michael.
Well, that was probably a great lead-in to sort of get us back into the utility realm. There were a couple of conversations this morning regarding it. I am going to talk a little bit about subsurface utility engineering, and more specifically, how the ASCE standard sort of goes along with that. So back in 2002, and this was kind of a collaborative effort between FHWA at the time and ASCE, the standards were developed essentially to start to create a common language between utility owners, designers, contractors, so that everyone started to talk about utilities in the same manner with respect to construction. The standard did become a national consensus standard, and it's actually right now in the process of its update. As you can see, it's supposed to be every 10 years, and we're now in 2020. Well, 2020 is when the next update's going to be coming out. So it's been a little bit late in actually coming out. So some of the things that came out in the standards were specific to the definitions to sort of, again, get the conversations to talk a lot of the same language amongst the stakeholders. Subsurface utility engineering specifically was certainly defined first off as a branch of engineering. It is to manage the risk associated with construction in and around utility infrastructure. It involves engineering. It also involves geophysics, as well as the survey of the information that's obtained from geophysics and the engineering interpretation of that geophysical information. So it is an engineering science. We talk about reducing and managing the risk. There are sign and seal requirements by law for engineering deliverables that are ASCE compliant. And again, it does create the common language. Now, some of the things that it's not, we've talked, or you've heard some conversations regarding having utility information from a GIS platform that may not have really any known accuracy level information attached to it. So that isn't what we're talking about with respect to the standards. The standards are very specific on how the information is applied. And it's not just a survey of one call marks that you might see from an 811 contract locate that's out on the ground right now, because those marks really aren't taking into account the engineering, the geophysical information, and then again the survey of the accurate utility data that's available. So two main methods, or two main aspects of subsurface utility engineering. First of all, being designated. So that is the actual two-dimensional geophysical locating of utility infrastructure itself. Using the appropriate equipment, supplying that equipment properly based on the ground conditions and based on the utility infrastructure that's in the ground. And then, of course, it's then surveying that information back to the tolerances and to actually the project datum of what you might be working under from a survey perspective. Locating, which is this a little bit of a switch from what's considered contract locating in the 811 world. Locating truly is the physical exposure of that facility using non-destructive technology, in most cases air, in some cases water, but it's basically exposing that utility from a standpoint of getting 100% accurate 3D location of what is in the ground and where it is in the ground. The last thing that not the last, but the last aspect of what we're really going to talk, or I'm going to talk about with the ASCE standards, are the definitions of what the quality levels. And this is really where the meat of the document came into play to sort of apply what level of information is that's been gathered, how it's being used, and then to the contractor, ultimately, what level of confidence, what level of risk am I taking on from the data that's been provided. 4 quality levels were defined. And essentially, it travels from a less certain accuracy to a most certain accuracy from B through C to B to A. Now, they are cumulative. Essentially, you can't get to quality level B data without having gone through the steps of C and D, and I'll get a little bit more detail of that as we walk through. But that's one of the aspects that's extremely important, is there's not the ability to jump straight to quality level A data without understanding the three quality levels that are previous to that. So existing records being the quality level D, this can take the forms of GIS information. It can take the form of good as-built data, which obviously we all know would be great if everyone did as-built their data, but most utilities don't actually take the time to do that. Record systems maps, anything that gives the engineer the ability to know at least what they're looking for and what may be in the ground within the context of a project. Quality level C then takes that data, applies it to above ground surveyed features, so valves, hydrants, so you can start to do some connectivity between what the records show and how that information is applied or was applied when the project was designed or when the project was installed, and then applying that to the above ground infrastructure that can be seen and actually can be surveyed from above. Then the next aspect really is the meat and potatoes of subsurface geoengineering, which is the actual geophysical locating of facilities, using appropriate equipment, using electromagnetics, using ground penetrating radar, using sonic methods, to then actually get a true physical understanding of what's going on underground from an above ground scenario. We then move to quality level A, which is, again, the actual physical exposure of the facility using some non-destructive technology to be able to know exactly not only what's in the ground, but exactly where it is in the ground. You can see some of the information that is gathered, not only horizontal and vertical elevation, but it is ground elevation, so we can then start to look back in time at what information we've got from a quality level D standpoint, where the records, what the information show, what the depths were supposed to be versus what they may be actually during construction. Okay, so now applying that to a risk-based model, what we're not basically saying that every project should be the same. We live in a world where project budgets have to be controlled. Obviously, without any SUE information, all the risk is basically going to the contractor to find out exactly what's going on because we're not giving you any information. As we work through the model, the more subsurface utility engineering information that we can obtain, we minimize not only the risk to the contractor, but also the risk to the design engineer, because the design engineer has to have the conversations with the owner of the project to say, this is our recommendation based on my professional judgment to tell you that we're doing this project. We cannot do it in a vacuum. We cannot work within having no information from a construction standpoint. Now, again, that doesn't mean that it's a one-size-fits-all problem. We need to find the appropriate line, or what we call the sweet spot, between the amount of appropriate information that's necessary for the type of project that you're actually working on. As you can see, we've got two different project risk lines on the slide on the right, and no two projects are going to be the same. A project in here within the city is certainly not going to need to be treated the same as a project out in a rural county where we know there may only be some buried telephone and the project may not involve a lot of excavation. So this is really what you start to look at. If you're getting a true subsurface utility engineering deliverable, you start to see that information is quantified. So every single line will have an understanding of what that information is. Is it a quality level D, or have we actually gotten quality level B information? Gives the contractor accuracy and understanding from a risk perspective on what they may encounter. Same thing with test hole information. That's all shown as well to give you a true feeling, not only from a design and engineering standpoint, but from the contractor's perspective of understanding what they may encounter out on the project.
So, Michael, what can we do to help encourage the industry to adopt things like this?
Well, we're starting to see a significant amount of contract language that's actually coming out in RFPs. It's taken a long time. Obviously, the standards came out in 02, and here we are in 19. But I would say that and Phil, you brought up in your presentation as well, we're really seeing a shift in some understanding finally about owners and actually contracting authorities defining what level of information they want. Because the understanding is there to reduce the amount of risk that you're passing out to the contractor. One of the things that we're focusing on now really is that it's the next step. We were sort of ahead of the curve for a long time in the industry on doing things by paper and on two-dimensional views. And now we start to get into 3D modeling and the 3D and really having out there BIM modeling and things to see, well, you're going to start to lose the level of understanding of the accuracy of the data. So things such as making sure that each line has data tags on it, and then to make sure that that information can be obtained and seen through the design and through the construction aspect really is where we're starting to see the next level of information become, because without a true understanding of what level of accuracy you have in the data, you have to know whether or not, how close can I be to designing next to this storm pipe or next to this telephone system. So.
Great. Well, thank you very much. Oh, I'm sorry, Alan.
Question: do you have any model legislation that, let's say, a city council or a charter or a commission would want to pass that would put this as a matter of law or requirement in a local government?
We haven't seen anything locally. We have seen quite a few departments of transportation that are moving in that manner. Now, part of the problem is that they're getting a bit ahead of themselves with some of the concepts that I was just explaining about. You don't want a 3D model to be turned over without a complete understanding of where that data came from, because the two-dimensional is easy to explain in the quality levels that are defined, but when you start to apply the third dimension, where did that third dimension come from? Is it from full-on MCGPR, multi-channel GPR system, so that you've got a true depiction of what the 3D model and landscape underneath the ground looks like, or is the third dimension based on record information? So did you get good two-dimensional information from an above-ground mapping standpoint, and then just take some assumed buried depths? Those are the types of things that really aren't, they're not far enough advanced whereby I really think from a locality standpoint, they're not really ready to have those conversations. It's good because the conversations are out there and there are requests for 3D modeling that are going out, but there has to be some more conversation, and that's some of the things that I know Phil and I both have been involved with in really getting out in front and saying, we can't just do this in a vacuum, because having, it's the old bad data is worse than having no data in some instances. You can get that false sense of security that this 3D model really is a clear depiction of what's going on, when in that third dimension it may not be.
So, Alan, was your question more directed on model language, to like the GIS model law that was in the past, 20-some years ago, or, I mean?
It would be starting the dialogue between the municipal authorities and the engineers with these latest, to at least draw a line where we have some certainty about what's going to work and what's good, to start this whole data quality movement and get it in and start a tradition of putting it, as a law, as a requirement.
So in a couple weeks in Nashville, ASCE Pipeline Conference will be a release of a SUIT guideline for municipality guide, and that explains the ASCE 38 standard and how to administer it,
right,
pre-qualifications, right, and put it at a level that can be used.
Yeah, it's sort of on the front end, because hopefully if we can get municipalities to the same place that a lot of DOTs and other design firms are with respect to the current standards, at least it's elevating everyone to that common language again, from a two-dimensional standpoint. It still doesn't completely define what should go into a 3D model, because I think it's great that we're having the conversations about it, but what a 3D model means to one municipality or to one engineer is completely different than what it might mean to others.